to cover actually. I want to quickly go over the latest innovations and optimized workflows, artificial intelligence, latest developments in software and resins, the difference basically between class 1 and class 2. What can we 3D print? The power of 3D dentistry. We have to talk a little bit about materials and safety. Well, I think we're obligated to do that. I also want to cover the basics of 3D printing and how does it work, because understanding that one makes you even better in what you're going to do. And what do we need? We talk about post-processing, and I want to give you some small tips and tricks at the end. Extracut has released not too long ago the Rayaka version. A lot of great new functions in that one. Not only have they got the Rayaka for the lab, but also the Rayaka basically for chairside. So it is a simplified version where you can just quickly make your crown and bridgework or any other appliance you would like to make. For some reason, it keeps going back. Let's try my keyboard. So what we also have nowadays is something quite new, and that is called Blender for Dental. Blender is a Dutch program, actually. It's a 3D animation program. And two brothers in Brisbane, Australia decided to make add-on modules for this system. And these allow you for a very reasonable price to have basically a CAD program with different type of models. You can make models, you can make, if you have an all-on design and you want to split the overstructure with the titanium base, for example, you see in the picture on the right bottom corner. It is really easy to make really great designs with this software. So again, this also is something that's very new. What is really new with all we have is artificial intelligence. So we got machine learning and artificial intelligence, or actually I have to say machine learning is a part of artificial intelligence, because artificial intelligence is the entire name for a lot of things inside that field. But basically what it is we take the information we get when we design a crown. All that information is being pulled out of a design system. It is being put into a computer system and it learns from itself. So the more designs we do, the better our automated learning system will be. So input creates output, actually. I hope that makes sense. Otherwise, I can explain that a little bit more later about it. But it's really cool to see what all these companies do nowadays with artificial intelligence. For example, 3Shape has, with the Trios and with the Unite, they got the scan assist. So you got better scans, better stitching. With Smile Design, they do teeth suggestions, Implant Studio, auto alignment. And the model maker is basically directly modeled from scanner with just a couple of clicks. Very easy. In Extracut, you got dynamic occlusion, margin line detection, anatomic freeforming. And with Medit, we have artificial intelligence abutment and artificial intelligence scan body matching. It works really well. Oh yeah, and what also really cool is the new one is the splint design. So basically with a click on a button, you get a proposal. And actually they're very good. So that's definitely something to look into. I have one of the very few Zirconia printers. So I am able to 3D print Zirconia substructures, copings, monolithic, even full arch. All these materials are all approved. There are currently only 2 on the Southern Hemisphere, and I have one of them. It is really cool because with this way we can 3D print, and like I said previously, our substructures or monolithic full contour crowns. It is really accurate. The fitting is just, I have been absolutely blown off my feet with how accurate these prints can be. And the aesthetic results, we're getting there. These materials, these Zirconias, are still the Yttrium 3, and the Yttrium 4 is just basically in development and in testing. And we're also already looking at the Yttrium 5, so the more translucent Zirconias. And if we can do that, we can have full arch Zirconia. Let me show you, for example, this one. And this is the great thing, we cannot mill this accurate because we have the limitation of the size of the milling burr. And we don't have that problem when we do additive manufacturing like 3D printing. This full arch crown, or full arch bridge, I have to say, sorry, is just out of the printer. I have not done anything. I have not made any adjustments to it. So you can see how accurate it can be. So we have already like a couple of things, and 2023 will definitely be the year of new materials. Like I said previously, I work with a lot of manufacturers, and I talk with them and I test a lot of new materials. And this year there will be coming a lot of new materials on the market. I can't tell you too much, unfortunately. I wish, but sometimes we have to keep things a little bit quiet until it's nearly there or it's there. But trust me, 2023 will be the year for additive manufacturing. All these innovations allow us to work more precise, faster, easier, but also permanent. And permanent is, I would love to rather say, long term. So we've covered now a lot of things, like we've got the newest scanners, we got the newest resins, we got the newest software. All this allows us to be basically on top of our game. And I always make a little joke. I create smiles. What is your superpower? And I think there are so many. I think as well, we're all in this industry. We want to do the best for our patients. We want to give them the best smiles and give them confidence in their life again. If they haven't had it, of course. But like I said, I create smiles. What's your superpower? One of my other superpowers is, I would love to say, 3D printing. I'm absolutely the biggest advocate and biggest super fan and nerd of 3D printing. But one thing I'm also very excited about actually is lingual retainers. This one is one I created in Zirconia. So I 3D printed this one in Zirconia. And the good thing is it fits so well. It's just insane. You can even do a lithium disilicate bonding, for example, on the inside. So you can do a normal bond. And it is absolutely great, the results you can get. You can even do it with any type of PMMA, or for example, let's say a denture tube material, we can 3D print it and you have a great lingual retainer. Also, what we can do is, for example, a full arch, an MUA or direct to fixture. Now I've got a sample here. That's a TRI implant system, and it's directly to the implant. So there are no tie bases or anything in between. It is very strong. It's a great way of even making a temporary bridge or permanent if you would like. You need more advanced knowledge about implant cases, but the accuracy is just absolutely insane. Also, what I absolutely love is trying dentures, immediate dentures. There's always still a discussion like, oh, I don't think permanent dentures is good enough for 3D printing. It really depends on the material you're using, but definitely trust me, it is there. We can 3D print excellent dentures with a beautiful suction in the mouth. I'm a big fan, like I said previously, about the Ceramco Crown Tech material. It's very aesthetic because it's silica glass infiltrated. And as soon as we go into the incisal edges and it becomes thinner, light comes through, it's just beautiful. But if we combine this, for example, with the Denture 3D Plus from NextDent, we got actually the best of two worlds together. It's a very strong base. It's a very aesthetic looking base. It's easy to adapt where it's needed. And you can even reline it. So we're combining two excellent materials in that way. What we can also do, for example, is temporary and permanent crowns. The industry-proven materials and the newest generation hybrid resins allow us to make permanent crowns. Long-term, I prefer to say again. So we've got a lot of these materials. We can now make something that is TGA cleared, FDA approved, FDA cleared, CE approved restorations. It's just absolutely amazing what we can do. I am using a lot in my laboratory, and it allows me to work much more precise. I know already what I'm getting. All my equipment is fully calibrated. So I know every time I put something on, I know what I can expect. And if something goes wrong, it's just a matter of pushing that button again. But I can do by myself the amount of work that I used to have 3 technicians to do, because all this digitally allows me to work more accurate and faster, of course. Talk about faster. For example, if we're going to 3D print a crown, this is a crown calculation I have done on the NextDent 5100, and then with the crown tech material shade B1. I am going to print a crown within 20 minutes, and I only use 7.3 grams of this material. Not only that, this reflects to me in basically the material cost of that crown of $7. Okay, I know all the clinics will now say, oh, but the crown is too expensive. No, it's also you need all the equipment. You need a trained technician. You need to have the proper CAD program. All that thing costs money. So no, that doesn't mean we can do crown and bridge work cheaper. But I just want to tell you, like, these costs do not have to be that high internally for that part. Hope that makes sense. I want to show you some examples of some cases I have been doing with Class 2A approved materials. And for example, this one is an anterior crown in an A3 color. All I've done is a little bit of polishing. And you see, we get a really high aesthetic result. This one also, just the color is absolutely brilliant. I think it's very spot on. An A3. Also spot on base color. An implant case, and this is, for example, this material is also completely holistic. And this is an implant that is a full Zirconia implant with carbon fiber screw system. So I got a holistic implant system with a holistic crown on top of it. So this is for a holistic dentistry a really good solution. And this is long-term approved. A very simple little crown, nearly an onlay we can almost call it. This one was an interesting case. This is a case I've designed fully digitally. So it was an intraoral scan. I've designed a flexible partial actually on that one. That's been milled, but the teeth are fully 3D printed. And we just put that with cold curing all together. This is a premolar we put in. The picture is not the best, but we have really great aesthetic results. This one is one of the few I'm really, really proud of. This case is done with only basically surface texture and polishing. So no staining, nothing else has been done. And we've got a really, really aesthetic result. This is a bridge that has been done by the university in Zurich. They made a temporary bridge. Well, if anyone says a temporary bridge, don't make them too beautiful. Patient is never coming back, by the way. So I have to give full credits to these guys. They've done an excellent job in making an absolutely aesthetic bridge. This was a more complicated case. Unfortunately, I don't have a shade tab with this one, but we had to create a C color. And we all know a C color is one of the most difficult ones. Whatever we're going to make, even if it's a Zirconia, normal PMMA, it's difficult to get to. So what I've done, I've used a completely white resin. Completely white, stained it up, and we got a beautiful matching C restoration. Also, what I would love, this one is a really good, is actually from one of the clinicians I work with. I'm really proud to work and know this dentist. And this is for a patient who had a jaw cancer. So they removed part of the jaw, took some parts of the bone out of their legs, put that in and put this bridge on it. And those claspers to hold everything in place. And this stays long-term in the mount until everything is healed and they can replace the restoration. And it's absolutely amazing to see what is possible with now new materials. The other thing what I have, for example, is here we see a crown on the 2-1. And it is just a crown. This will stay a year and a half to probably 2 years inside the mouth. And then we're going to replace it for a final one. But I think for a 3D printed crown, just a little bit stain and glaze, I think we've got a beautiful solution. I mean, whoever says 3D printing and aesthetics are not there, I think I've proven different in this case. So we really redefining 3D printing and dentistry, what we can do now with additive manufacturing. Another example, and this is not a class 2A, but this is class 1, is splint. It's a combination but of a Michigan splint, but it's really like it just fits. This is, for example, with Keystone Soft. I love that material because when it becomes on body temperature, it removes any fitting stress, so it's very comfortable for the patient to wear. All these things, we have now seen the examples also, and everything, all this is the power of 3D dentistry. We are now able to enable a service to our clients like we've never done before. And like I said, everyone who says, oh, it's not there yet, or we can't get the aesthetics result, it is there. The materials are there, the workflows are there. It is just everything that's new takes time. Spend that time and you will see within no time you are a master in 3D printing. And the software nowadays for 3D printing also makes it a lot easier. And if we talk about 3D printing, what are the initial benefits? And if it's chairside or in the lab, it really doesn't matter that much. We have a huge amount of benefits of 3D printing. And one of them is we are using a high accuracy technology. We know what we can get as long as our equipment is clean and properly calibrated. I keep hammering about that also within our company, like everything is spotless. Our lab is just, you can eat off the floors that clean. I find that very important. Not only that, we want to use minimum or minimize the amount of human errors, because where people work, we make errors. Where equipment works, we can, if everything goes well, we can always expect the same result. Big benefit, we don't have to pour up a plaster model. We as Dentique, we don't even have a plaster room anymore. I don't have a plaster room for the last years because I don't think it's necessary anymore. Not only that, like I said, also a couple of times, it's reproducibility. So if something goes wrong, we hit one button and we have a new crown, we have a new splint, we have a new denture, everything we want to do. And again, this is also a little bit with a joke, but it performs on Monday the same as on Friday. And why am I saying that? Well, we all know, especially, look, we all work with staff, but we all know we had a great weekend and Monday, with hangover or whatever, we had a great party. We have to get into it. On Friday or Thursday and Friday, we're already like, hey, it's almost weekend. What are we going to do? So the focus is gone. So really, the real moment when someone is really focused is on Wednesday. Take it lightly as a joke, but technically it is true. Not only that, is when we are 3D printing, and it doesn't matter how big our team is, we can do it ourselves. We can do it with our in-house team, if it's the clinic, if it's the lab, or if it's a clinic, you send it to the lab. Whatever you want to do, you've got full control. And we have full control in design because you can check the design, you can approve the design. We got full control in cost because we can keep the cost low. And we have full control in time management because there is less manual work. We are able to output faster when it's needed, or we can even combine prints together to get a quicker run through. Not only that, if we talk about clinical, for example, chairside 3D printing, is when we are using digital technology, we can reduce, for example, the chair's time. And if we do a crown, we can go from 2 to 1 visit, and a splint from 2 to 1 visit, and a danger, for example, for 5 to 3 visits. Material cost, I said it previously. So if we use approved materials and validated materials, and I keep saying that all the time, that is very important, we can have really good results for a really nice price actually. A crown, roughly around $7 US, a splint, material, this is only material cost, roughly around $10, and a denture, roughly $20. Of course, these on average and depending on the resins you're using, but it gives you a clear idea. So what kind of other benefits do we have? And there are actually more benefits to 3D printing than we have with milling. For example, we don't have any milling dust. We don't have that noise. Those are two big issues always in a laboratory. And we want to keep it clean. We want to be in an environment that doesn't hurt our ears. So we don't have that with 3D printing. We don't have any broken burrs. We don't have any real maintenance costs because there's no spindle. There are no 5, 6, 7 axes what we're working on. We don't have real consumables except for the tray and the resin. We don't need a high-end compressor, what is very costly. We don't need a separate vacuum system for it. We don't need an expensive additional CAM software because the CAM software or the nesting/slicing software is included. And what I find really a big benefit is no drill compensation. And therefore we can make a restoration that is much thinner, but also much more aesthetic. And for the ones who is like, what is drill compensation? Let me quickly go over that one. Please allow me to have a sip. So what is drill compensation? Well, I've made a drawing here and my drawing is not the best, so please forgive me. But what I want to show is really what it is and what the benefit will be when we do 3D printing in comparison with milling. So we've got our die, it's a cross section of the die. Now I'm drawing the inside of a crown. This is a beautiful anterior crown. I think nobody has ever seen a crown like this. But the problem is when, on the clinical part, the incisal tip has not been rounded and is very sharp, we have difficulties with our milling burr on our milling machine to get into that region. Let's say, for example, that milling burr is, okay, 0.6 or 1 millimeter, whatever we would love to call it. It really depends on your system, what the possibilities are. But I'll say, okay, this is 1 millimeter. If we have a 1 millimeter drill and we want to get all the way into the top of the crown, we can't reach it because it's already touching the sides. So what the software is doing, that's called a drill compensation. It hollows out an extra part so the top of the milling burr is able to get to the top of the rest or the top of the preparation. And that is called drill compensation. It is a great way, but there's one big disadvantage of that one. Because it hollows it out from the inside, we have less space, and I hope people can see my mouse, from the incisal, from the labial area to the inside of the preparation. This area here is, I think, let's see if we can, I think we can mouse there. Now you can see my mouse, sorry. Here, this area is becoming thinner. So if this is a thin restoration, we might see a black area or anything. So if we don't need any drill compensation, we got the full amount of material here. So we can work much thinner, much more aesthetic. Okay, so I think this should be quite clear what it is, otherwise more than happy to explain it a little bit later. But before we start with anything else, let's see, there it is I also would love to talk a little bit about safety. personal protection and safety. And I find it very important to discuss this also because we are still technically working with a chemical. So always work on a stable surface or a table. And don't have your printer or your cleaning station on a wobbly table. I had it so many times. I come into a lab and they say, oh, it's not as accurate. And I walk to that table and the table is just moving. Yeah, of course, it's not a stable print. So work on a stable surface. Also work on an easy to clean surface. For example, all my printers are on stainless steel. So well ventilated area. We need to have safety goggles, nitrile hand gloves, and use a lab coat. I want to talk a little bit about materials and regulations. So the golden rule I always hand, and there is always a discussion point, but I say if it's a short-term contact, I would like to classify it as a class 1. So a custom tray, surgical glide, try, indenture, or a splint. If it's anything that is long-term inside the mouth, like a lingual retainer, a temporary crown, permanent crown, a denture, an RPD removable, whatever stays longer inside the mouth, classified as a class 2 or class 2A. All right. Well, I want to quickly go over a little bit of basics about 3D printing. And the basics of 3D printing is really building a layer upon layer until we have created a three-dimensional object. But what is very important, for example, we got an object height 0.8 millimeters, and each layer we're gonna print is 0.2. I only need 4 layers. So I need 4 layers to come up to the 0.8. So if each layer, let's say, takes 10 seconds, this object to print is 40 seconds. Just give it a number. If I make the layer size smaller, let's say half that one, so 0.1, I don't need 4 layers, I will need 8 layers. What will that do with my time? My time will be, instead of 40 seconds, will be 80 seconds. It doesn't change anything, it's just I got double the amount of layers, I got double the amount of print time. And this is, so object height divided by layer height is my print time. But my time times my layer height is my object height. So I got more time, more layers, I got a higher object. I hope that makes sense. Okay, a lot of people talk about accuracy, and accuracy of a printer is really only on the X and Y dimension, and that is where the accuracy is, and not on the Z. So people talk, my printer is 50 microns accurate. No, your smoothness is on a Z level 50 microns. And I can show that, for example, here we got a pyramid, and we all can recognize the shape of the pyramid, but the one on the right is much more accurate, looks more like a pyramid. Also here, the half a circle or dome, they're both the same height, the same shape, but it looks more smooth and more details on the right side. So like I said, we're building layer upon layer. So what's happening? We have a tank of liquid, and that reacts with UV light. We have a platform that goes down until we have a thin layer of liquid. Underneath, a light goes on, light goes off. It pulls it up, and it should stick to the platform. Goes back down again, creates another layer of resin underneath, light cures, solidifies that part, and it does the same again. And all that time it's building up an object. So like I said, that is a resin, and that is a photopolymer, and that will react with UV light. This was invented in 1984 by Chuck Hall. He is the founder of 3D Systems, and they are still the biggest company in 3D printing. He really invented this system, and look at what we do nowadays still with it. We're absolutely amazed what the options are. And like I said, we got a platform. That platform has a transparent bottom, by the way, in this case. That is like, I always like to love to call it a Teflon. Underneath is a UV light, and that solidifies. And we got different ways. We got different type of printers. We got, for example, an SLA, Formlabs. It uses one laser point and it goes through the entire object. It is very accurate in SLA because a laser is round. So we got very sharp, nice edges. But because it has to touch every part of it, it takes longer. The technique we're using nowadays more and more is basically the DOP SLA, and that is like the Nextend or a SIGA, and it's using a projector underneath, and it projects the entire object as once. And the new part we have is the masked SLA. Those are the new type of printers. For example, we got the Accuretta, Frozen is another famous example. They work with an LED screen. So every printer has its advantages and disadvantages, and we'll talk a little bit about that later also. But what do we need when we're gonna start with 3D printing? We need a validated workflow. We need an intraoral scanner or a lab scanner. We will need to have a proper CAD software. We need to have a proper CAM software that knows what to do with that designed file. So we got our STL file, and all that the software is doing is basically grabbing that object. It acts like a Japanese chef. It cuts it in very thin slices, and it says to the printer, please start printing with slice number 1. So there are really good softwares nowadays for that available, and they come with the printer. And of course, we need a 3D printer. And there are so many. We got the Accuretta, we got the SIGA, Formlabs, Nextend. There are so many. I can't even discuss all of them. We don't have enough time, and we're almost running out of time, I've noticed. But let me quickly go over some of the printers. Now, what else do we need? Well, we need to have certified 3D printing resins. A lot of manufacturers are on the market like, oh, we are validated. No, they are not. A lot of them are not properly validated. So make sure to do your research and be informed by the reseller that you have actually an approved resin. In the end, it goes into the patient's mouth. And for some resins, they recommend to have a mixing system. So instead of shaking the bottle and shaking air inside, it just rolls around, and we got a properly mixed resin. And that is very important to create high accurate prints. We need a washing. Sorry?
Just we have some limited time, so
I'm nearly done. Give me 2 seconds. I'm almost done. We need a washing. We need a washing solution, and we need to wash our prints, and we need a light curing system to finally light cure. 3D printing itself is only 30% of your workflow. Everything else, washing and light curing properly, is really what determines if your print was a success or it has failed. So why we do it? To clean object from any uncured resin and to get the accuracy on the X and Y, and then the smoothness, of course, on the Z dimension. Okay, and this is all to comply with any regulation. And the clean with about 95% IPA, or use an automated cleaning system, or use an ultrasonic, for example. That works well. Light curing, get yourself a proper light curing box when you do a class 2A material. A quick tip, design only what is needed, so you don't have to print any additional. Use small micro brushes to clean. If you nest any teeth or anything, do it with the label area towards the platform. You get a more smooth surface. I use IKEA trays to basically get my print out of my printer so I don't drip over my printer. Those are just very small IKEA trays, couple of dollars, done. And use some spray bottles for your IPA. So nice and easy. Trust is also something. Choose the right software. Choose the right hardware and choose the right materials. Make sure you got validated workflows and choose your right partner. You will need to have support. Go to your reseller and make sure your reseller knows what they're doing, and then choose them. So make sure you got a certified workflow.